Hey, 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 what's up, what's up, what's up, what's up? Who loves open source? If I say open source, can you say hell yeah? If I say open source, you can say hell yeah. Yes, I love it. Thank you. So I'm Daniel, and picture me. I'm at work here. I look happy, but I'm actually very sad. I'm writing closed source software to compete with open source software that has more momentum, more features. And of course, now my company is in decline, and all of my hard work and code is going to disappear. Has this happened to you? But we have bigger and better ambitions. We want to build great software that lives on and to help people. So I want to show you some examples of collaboration platforms in robotics, cloud computing, and cancer research. But first, what makes a good platform? Standardization. Standards enable a frictionless collaboration. The greatest standards, in my opinion, are international shipping, the metric system, TCP/IP. We can build more of these and build on them more. You might ask, why though? I'm pretty sure Adam Smith said, teamwork makes the dream work. He was a smart guy. One company trying to do everything on its own is prohibitively expensive. You can concentrate on the things you're good at. I can concentrate on the things I'm good at. We can exchange, and then we're both really much better off. Adam Smith's ideas about capitalism will only survive as long as scarcity does, but his ideas about division of labor will never die. Today, you use division of labor every time you install a Python package from PyPy. A software platform has two parts, the common base layer and the tools that people build on top of it. And good platforms have standardization. 4 aspects of standardization are important. First of all, the installation needs to be a simple one-click or one command. Secondly, the documentation needs to be very clear and consistent across tools on the platform. Thirdly, the usage, how you run it, how you integrate different tools on the platform, and how you monitor those tools needs to be consistent across the platform. Using the tools should make you feel transcendent and all-powerful. Fourthly, contributing needs to be consistent and easy to develop and easy to share your code with others. So what does this mean? Let's look at examples. ROS stands for Robot Operating System. It's not an operating system, it's a framework. And amazingly, all of academia and industry build on top of it together. Amazon, Boston Dynamics, BMW, Bosch, Baidu, MIT, the University of Toronto here at home, and everyone else in the fields of robotics share on this standardized platform to exchange different pieces of software. Here's how that collaboration works. Hardware manufacturers contribute software packages that publish the sensor data into ROS. And then universities publish packages that take sensor data and compute a map of the world or something. And then other people's software takes the map of the world and a positional goal and compute a path and publish motion commands. And then still other people translate the motion commands into voltages that control the motors. ROS is the best open source collaboration that I've seen, and I fell in love with it. This is my robot. It's fucking awesome. It's got It's got 6 wheels, an arm, a depth camera, is able to avoid obstacles, pick things up, and be remotely operated. In less than 8 months, me and a 13-year-old from Toronto's Hack Lab built this as our first robot. We have to give a huge thanks to ROS. Because of its consistency, we could very quickly pick up existing tools and put them together and build an autonomous vehicle with very little coding. I published a book chapter on our design and contributed a few new packages as well. This is what it looks like to develop for ROS. It has beautiful consistency and conventions. The user interface is powerful, and you have lots of strong tools to use. Here's the command line interface that is consistent across all of the components. Our second success story is OpenStack. OpenStack is the de facto data center framework. It's huge. Think of it like installing your own AWS or Google Cloud in your own data center. OpenStack will keep your users in your data center separate or connect them using advanced networking protocols and link them to data storage hardware of any kind. It allows you to provide users many kinds of services, like database as a service, object store as a service, serverless as a service, DNS, and so on. But people say it's complicated and that you kind of have to be a wizard to use it. But do you? Or do you become the wizard? Because OpenStack is so standardized in terms of installation, documentation, usage, and contribution, you can become the administrator of a data center very quickly. You're a wizard, Harry. So the documentation is consistent and beautiful, like for this Python API, or for this configuration file, and it's consistent across tools. They have a strong command line interface, and I really recommend OpenStack for your data center. Finally, and this last part is the most important part, if we don't get cancer research right, we're dead. Nothing else matters. There's tons of different kinds of biological images, from ultrasound to electron microscopy, and thousands of ways to measure images for scientific questions and for patient diagnosis. When I was doing my job at Sick Kids, analyzing different kinds of images, I looked for open source tools like I'm used to, but I was really very disappointed. There's no good platform out there. And it's an atrocity that despite the massive research budgets in life sciences, I still had to reinvent the wheel and code this from scratch. We're just 2 blocks away from the hospital for sick children, and the kids need us to find breakthroughs. But just look how bad this software is. This is ImageJ. This is the most popular image analysis tool, and it has 0 technical swag. It's based on Java, and support for any other language comes through compiling your code to Java. There's no package manager for you to pull different tools from. It's just people have jar files on different corners of the internet, and you have to download them. Command line tools are almost non-existent. Automation requires strong coding skills. Documentation of plugins is a patchwork of differing conventions. Installing a new plugin is a 4-step process that requires you to close and reopen the software, and everything are these drop-down menus. This is not even the longest drop-down menu. That's cancer. And secondly, let's look at Self-Profiler, the most popular open source tool for image analysis of cells. Do you see the tutorial link in the corner? When I clicked on it, it's actually a 13-page PDF of an academic paper. This platform is not built for developer productivity, and the sick kids are dying. Even the lead scientist who built that software has published publicly that much can be gained simply by better organization of the current state of the art. If you want to join me in solving this massive problem, please email me. We have an opportunity to change the world with an open source image analysis platform. Lastly, today is Remembrance Day, so let's remember to not fight over scarce resources, but to try and bring abundance and health for everyone. What are you going to add to the global operating system? Thank you.